Okay, so the next thing we're going to talk about is we're going to talk about absolute values with inequality. Specifically, we're going to be talking about cases where you have a less than sign there. Okay, and we're going to look at an example on a number line before we get started here. So the first thing I want you guys to do is I want you guys to make a list. What are all the possible x values that could equal and make that true? Okay, so right now, what could I plug in for x and still make that be less than 4? So pause the video, write down those values for me. Okay, hopefully you guys have paused that video and you guys have wrote those down. A lot of you guys, I'm assuming, would see that you could put 0, you could put 1, you could put 2, and you could put 3. That would all be less than 4. I could put 3.9. That's still less than 4, right? So all of the numbers that are less than 4, we could fill that in. Would you guys agree with that? Because, I mean, -1 would work, -2 would work, -3 would work, -4 would work, -5. Those are all less than, right? Ooh. If I plug those in, would that still be true? Say I plugged in an absolute value of -5. What is the absolute value of -5? Well, the absolute value of -5 ends up being a +5. And is 5 less than 4? No, it's not. Okay? So actually, I lied when I said all of our numbers less than 4, didn't I? Okay? We could do -3. Absolute value of -3 would work. And in fact, I can make that an absolute value of a -3.9, right? -3.9 would work as well. But anything below that, so not including that -4, anything below would not be answers for this. Okay? So this is important because what we see here is we see that any number, from -3.999999999 all the way to 3.9999999, all those numbers here in the middle, those are all of our answers. We could not include 4, could not include -4 because it's just a less than sign. And what do we get up here when we see that? Well, we see that the absolute value of x less than 4, that's really the same thing as -4 less than x less than 4. Okay? So essentially, when we are dealing with less than signs, we end up having bounded intervals. Less than signs ends up giving us bounded intervals. So we can make a statement here. We're going to make that down below. The absolute value of x is less than a. Okay? If we see that the absolute value of x is less than a, that implies that we are going to have a bounded interval, and it's going to be stuck between -a and a +a. Okay? And that's the most important thing you need to get from this. If you have an absolute value of x is less than a, absolute value of x is less than a, you set up a bounded interval. If you guys remember the last time with equations, we set up 2 equations. Well, we no longer set up 2 equations. We set up a bounded interval if it's a less than sign. Okay? So let's practice here. I've got the absolute value of 2x plus 4 is less than or equal to 3. Okay? So the first thing I do when I look at this is, first off, make sure that it's isolated. It is. Then I'm going to look at my inequality sign. That is a less than sign. So since that's a less than sign, I'm going to think back. Absolute value of x less than or equal to a. Okay, well, that implied -a less than x less than a. It implied a bounded interval. Okay, so I'm going to look here. Got an a in this spot. I'm going to need a -a and a +a. So 3 is in the same spot as the a, right? So I'm going to have a -3 and I'm going to have a +3. My x, the part in the middle, right? But instead of an x, I have a 2x plus 4. So in the middle where that x is, I'm going to have a 2x plus 4 here. Now the only difference from the last time is that last time we just had a less than sign. Now we have a less than or equal to. And that's just going to make those two less than or equal to's as well. Okay, so last time we isolated. Once we had it isolated, we set up 2 equations. Now we've got it isolated. We see a less than sign, so we set up our bounded interval. Remember, when we're solving these bounded intervals, I'm just going to go through. Whatever I do in the middle, I do to the outsides. So I'm going to subtract 4 everywhere. Okay, when I do that, I get a -7 less than or equal to 2x less than or equal to -1. I'm going to divide both sides, or divide everything by 2, not just both sides. Okay, And when I do that, I get a negative 7/2 is less than or equal to x, which is less than or equal to negative 1/2. So any numbers that fit in this section here between negative 7/2 and negative 1/2 will make that statement true up there. Okay, a couple more practice ones to do here. You're going to kind of have to jump around in your slides. It looks like it's slide 12 and 13. Okay, you guys can do this one here. Okay, and then go down to the next one, and you guys can do this one here. Now, with this one here, what do I need to do first? I hope you guys are saying that you need to isolate that absolute value first, because that would be correct. Okay, so pause the video, do just those two. Do the two on the left side. Those are the only two I want you to do. Okay, so hopefully you guys have paused that video. Okay, remember our first step, okay, is that we need to make sure that our absolute value is by itself. It is. Next step, I'm going to look at my inequality sign here. Look at my inequality sign. That is a less than sign, which means I'm setting up a bounded interval. So since I have a 4, I'm going to have a negative 4 and a positive 4. It's less than or equal to, so these are going to be less than or equal to signs. And then what do I have in the middle? I've got a 3t minus 2. Okay, so now that I've got it set up, I'm ready to solve. Add 2 to both sides. Okay, that ends up giving me a negative 2 less than or equal to 3t less than or equal to a 6. Divide everything up here by 3. And I end up with a negative 2/3 less than or equal to t less than or equal to 2. And that's my answer. Okay, next one then. This one we talked about, we have to isolate this first. So that's a positive 2, so I would need to subtract by 2 first. Gives me an absolute value of 2 minus 3x less than or equal to 4. Whoops, not 4. Less than or equal to 2 now. My bad. And I forgot my absolute value there. Okay, now I'm looking. I've got it isolated. That's a less than sign. Tells me that I'm going to set up my bounded intervals. So since I had a 2, I'm going to have a negative 2 and a positive 2. Less than or equal to, less than or equal to. Okay, and then my 2 minus 3x is in the middle. Okay, again, isolating this. That's a positive 2, so I would need to subtract 2 to get rid of that there. Got to do that everywhere else. Okay, I end up with negative 4 less than or equal to negative 3x less than or equal to 0. I've got to divide everything by a negative 3. Hopefully that kind of trips a trigger there for you. Okay, what is negative 4 divided by negative 3? Well, it's a positive 4/3. 0 divided by negative 3 is 0. We have just an x in the middle. And since I divided by a negative, I've got to flip these signs here. Those are greater than signs now. Okay, I would not count that wrong if you guys wrote it like that. However, the standard form for this, they want them both to be less thans. Basically, you just want your smaller number on the left side and your bigger number on the right side. So you could rewrite this as a 0 less than or equal to x less than or equal to 4/3. And that's probably more correct. That's more correct than what this is. Okay, so there's some examples of the less thans. Next video, we're going to go over greater thans, and we will finish off your guys' notes.